In a previous video, I used a metaphor to describe the difference between classes and objects. And in this case, I'm showing the difference between two Corollas that are very similar but have different colors, different trim levels, so on and so forth. Now in this video, I want to go back to the program that I've been writing, and I want to show all of the things I was demonstrating in this previous video, but I want to show it in code. So let's get started. First, I have my project, and frankly, it's a little bit cluttered for the demonstration that I want to do, and I really want to go back in time to a simpler version of this project several videos ago. Now, the good thing is with GitHub, I can do this. If you don't care about GitHub or you haven't used GitHub before, feel free to fast forward the next couple minutes as I revert my project to an earlier version. Now what I want to do, you see currently I'm at nested loops array with companion variable. The loop stuff is great, it's just going to kind of clutter up our view a little bit. So I want to go back to this commit that I made, show multiple objects from one class, because this video is about multiple objects. Now take a look and just kind of remember a couple of letters or numbers that you see here. BD7CD0A, show multiple objects from one class. If I want to go back in history, I go to Vehicles, and I choose Git, and from Git, I'm going to choose Checkout Revision. Checkout Revision means I want to go to a specific revision. So I'm going to choose Select, and I'm going to go back up to Master, and take a look, show multiple objects from one class, BD7CD0A. You might remember when I said remember a couple numbers or letters. Some of those might make sense. So I go ahead and I choose Select, and I'm going to check out as new branch, and I'm going to call this multiple objects, no loops. Now, why am I checking out as new branch? I'm checking out as new branch because I'm just reverting back for this video, but eventually I want to go back to where I left off prior to this video. So check out, and if we take a look, we see that I have the source code now that does not have the looping, so it doesn't have a bunch of clutter. However, it does have two different variables that are similar, my vehicle and your vehicle. And this is what I want to talk about, because it's very similar to the two Corollas that I showed in a previous video. Okay, so now we're ready to go. We've passed the get part, and we're ready to take a look at our comparison. So first of all, my vehicle and your vehicle. Now that we know what a class is and an object is, I would like to describe what these two lines are. It will make a little more sense if I can do a bit of an animation, though, so let me pop up a presentation here. And first of all, vehicle, my vehicle equals new vehicle. That should look familiar, because it's exactly this line number 30 right here, what I've highlighted in blue. So let's look at this line one at a time. First of all, we know that the classes or the objects of a program are essentially the nouns of that program. So vehicle, this first word is a variable type. Remember, when we declare a variable, we need two things, a type and a name. So here, the variable type is vehicle, where vehicle is a class that I have created. Back in NetBeans, what you see is I can hold Control and click on vehicle, and it takes me to this class named vehicle with a method named go, which hopefully you recognize from some previous videos. So vehicle is the variable type. Now what's my vehicle? My vehicle is the variable name, and remember that variable name has to be unique. In other words, a variable name is like a parking space. Only one car can be in there at a time, so the name has to be unique. Okay, so just a normal variable declaration, just like int miles per gallon is a variable declaration where the type is int and the variable name is miles per gallon. So what do we have on the right side? Well, first we have an equal symbol, which is the assignment operator. It's not a comparison operator. It's not comparing what's on the left to what's on the right. Instead, it's performing the action on the right and assigning the result of that action to the variable on the left. So what is the action on the right? Well, we see a keyword new, which is a constructor call. A constructor call means we are creating an object. Or in other words, we are instantiating an object. So it's like stamping the stamp and filling out the address label, or pulling off the form and filling out the fields on the form. We are creating an object when you see this word new. So what follows the word new? Well, the object type follows the word new, and in this case the object type and the variable type are the same, though that won't always be the case. When we look at polymorphism in a future video, we'll see what happens when these are different and how we can leverage that and write good programs by changing the variable and the object type. Now, one other thing you might say is this entire unit, the new vehicle, is a constructor call, kind of like a method call, but a constructor call is special because a constructor is always creating an object, and that object is being stored in this variable, myVehicle. So what's this line? Vehicle your vehicle equals new vehicle. Very similar to the line above, but in this case we are creating a separate object, and we're storing that separate object into a separate variable called your vehicle. Both objects happen to be objects of type vehicle. So that's the creation of an object. Now remember that an object or a class is essentially a noun, and an attribute is a special type of variable that describes that noun. An attribute is something that we will call an adjective. So adjective describes a noun. So small dog, small is an adjective, dog is the noun. And you could also have say a brown dog or a brown furred dog, so brown would be an adjective in that case. Now, to be one of these attributes, it has to be what we call a field or a member variable or an attribute. Those words tend to be used interchangeably, and frankly, it depends on when you learn Java, because we initially called them one thing and then we changed the name. But field, attribute, member variable all essentially mean the same thing. And they are these variables which are declared within a class, but not within a method. Let's remember the three categories of variables. I've just described attributes, fields, member variables, declared in a class but not in the method. More importantly, they describe the state of an object, where an object's state is the value of all of its attributes. In other words, a silver Toyota Corolla. Well, in this case, the color is silver, and that is an attribute. Now, let's not confuse attributes, fields, and member variables with the other categories of variables that we have. A parameter variable, which we'll see on the next slide, is a variable that's declared in a method signature, and in this case, we're passing a value to a method. A local variable is a variable that's declared within a method, but not a parameter variable. It's declared somewhere within the method body. Could be declared within an if test or within a while loop or any kind of loop. It's usually meant for temporary calculations, some kind of in-flight calculation. Let's see some examples of these. Our Go method of our vehicle class has a parameter variable right here that has scope in the entire area that I'm highlighting right here. So it has scope within the method, but not outside of the method. Now on line 19, we see that we are declaring a local variable. So this is not declared where parameter variables are declared. It's declared somewhere within the method and has very limited scope. In other words, a very limited lifetime. So gallons consumed is alive in the highlighted area here, and it's just needed so that we can subtract the gallons that were consumed on this particular trip from the gallons of gas in the vehicle. So those are our variables. Now let's consider this method, and I kind of have a short, an abbreviated view of the method we were just looking at. And once again, I'm going to look at each of these words and describe them. Number one, this word public is what we call an access modifier. Public means that any other object can call this method. So an object of a different class can call this method. We're letting everybody in. It's a public area. We can also make it private. Private means it can only be called internally. In other words, a method can only be called by another method of this same class, more specifically, the same object. There are a couple others. There's one called package friendly, which is the default, and there's also one called protected. Those will make a bit more sense when we talk about inheritance, which we haven't talked about yet, so hold that thought for just a moment. Right now, just think public and private. Next, we have the return type, and that means when this method is finished executing, does it return some finished product? It can return at most one finished item. That item can be a primitive, so it can be an int, a boolean, a short, a float, a double, a character, or it can be a class type. So essentially it can return an object. So it could return a vehicle, for instance. It could return a string, for instance. So any of the primitive or object types can be return types, but a method can only return at most one item. Now, what does void mean? Void means it doesn't return anything. Void means, okay, when the method's finished executing, it's just done. It doesn't have to let us know what it did. Next, we have the method name. Method name is something that just uniquely identifies this method. Now, that method name actually does not need to be unique, provided that the parameter list is unique. Don't worry about it at this moment. That's a topic called overloading. We'll talk about that a bit later in a separate video. Finally, we have our parameter variables, actually our parameter type and variables. Notice that's plural because we can have 0 parameter variables. We can have 1, as I have here. We can have 2, 3, 4, 5, as many as we want. So while we can only have one return type in a method, we can have as many parameter types and variables as we wish. And then you see open and close curly, and that is the method body. That's where all of the logic goes that, or all of the behavior that this method is going to exhibit. Now, static is another keyword that we can look at, but we will cover that later. So that's a look at classes, variables, and methods in the Java programming language. In our next video, I'm going to run the debugger, and we're going to take a look at what happens with two different objects of the same type. We'll see how we can change the attributes of one object, and it does not affect the attribute values of another object of the same type. I look forward to seeing you then. Thank you.